Question number 2 of the exercise 7.3 says AD is an altitude of an isosceles triangle ABC with AB is equal to AC. So let's make an isosceles triangles first. So I made going to make an isosceles triangle. And this is an isosceles triangle made. And I'm naming this as mentioned in the question. It is ABC, where the length of AB is equal to AC. Further, it says that AD by, we have to draw an altitude, AD being the altitude. The altitude drawn here is AD. So we'll draw altitude obviously from A to this side, BC, this being the altitude. And it's named, it's named AD. So we'll name it AD. As you know, altitude makes an angle of 90 degrees on either side of the base. What we have to prove here further is to prove that AD bisects BC. AD bisects BC means we have to prove BD is equal to DC. This is what we have to prove. And in the next part, we have to prove that this angle, like AD bisects angle A as well. That means we have to prove these two angles as equal. So these are the parts that we have to prove, right? This is not given, we have to prove. So it's a very simple question where we will be proving these two triangles congruent. Needless to say, what are these two triangles? So we'll consider these two triangles, that is triangle ADB, and the other triangle, it is triangle ADC. We have AB is equal to AC, and this is given as it is an isosceles triangle with these two sides equal. We can also see that here this angle ADB is equal to the angle ADC, and that is each 90 degree as it is a perpendicular. We have one side common, that is AD is equal to AD, and that is common side. So therefore we can write these two triangles as congruent. The same triangle, that is ADB, is congruent to the triangle ADC, and these triangles are congruent by, that is one side and one hypotenuse and one right angle. So it's congruent by RHS. It's not by SAS, that's by RHS. So once the triangle become congruent, we can write BD is equal to DC. That's from CPCT. I'm marking this angle as 1 and this as 2. Or you may simply write the name of this angle. That also goes well. That is DAB is equal to angle DAC. And that's also from CPCT. Right. That's what we have to prove. Hence we can write that. Hence, we can write this as AD bisects angle A. Right. So we had two parts to prove. First is this, that is BD is equal to DC. That is the first part. And when we have to prove this at AD bisects angle A, this can be proved when we root these two angles, or when we prove these two angles as equal, right? This and this being equal.